normality. What is normality? Normality is a way of expressing the concentration of a solution. So that means when we have a solution and we dilute it with some water, so the dilution increases. So the amount of the solvent increases, right? But the concentration decreases. So that means on dilution, if you increase the dilution, the concentration of the solution decreases, that we already know. So is the normality decreases. So in this case, if this I'm having an N1 as a normality and N2 a normality after dilution, so N2 will be less than N1. Why? Because on dilution, normality decreases. Let's talk about the amount of the solute here. The solute amount can be expressed in moles, that we already know. But what if I tell you if there is another way of calculating, measuring the amount of a solute, and that is by the use of equivalent. And our normality takes care and they use the equivalent concept for calculation of the concentration of the solution. So normality is defined as the number of equivalent of solute in 1 liter of solution. So whenever you need to find the normality of a solution, you just have to find the number of equivalent of the solute in just 1 liter of the solution. So if you have more than 1 liter, so just calculate the number of the equivalent in 1 liter by unitary method. So by the use of unitary method, you know the normality of a solution of having V liter of that solution, so will be number of equivalent of the solute divided by volume, given volume of the solution in liters. So from this equation, we found out that equivalent of the solute is equal to N into V, right? What's mole? Moles uses the amount of substance, the whole amount of a substance. Whereas the equivalent uses the reacting capacity of the amount of substance. Reacting capacity of the amount of substance. So what does it mean? So we'll see that with some analogy here in this lesson. Now this reacting capacity of a substance is often shown by a number called N factor, right? Now we'll see what does it mean. Let's see and understand this with an analogy here. Suppose we have 3 classes, right? And in each of the classes we have, suppose, 10 students, 11 students and 12 students. So mole concept takes care of the number of the classes. Now if you ask you how many classes of 10th here, you will say just 1 class of 10th. How many classes of 11? Just 1, considering we have just 1 section for that. And what are the class of 12? Just 1 class of 12. But what about the number of students? So number of students are different in each cases, like 10, 11 and 12. So equivalent concept takes care of the number of the students actually performing there, because it's not the class which performs, it's the students that performs, right? So for different classes we have different number of students. So this is how the concept of equivalent goes. Now how, as I told you, this N factor tells you the reacting capacity, so how it is calculated for acids, bases, salts and redox reactions. And we'll see that we can use the N factor for calculating the equivalent even from the mole itself, right? So equivalent always considers the reacting capacity rather than the substance amount as a whole. So for example, if I take, suppose if I take an example of an acid which is an HCl. So at 1 mole of HCl will give you just 1 mole of H plus ion, right? 1 mole of H2SO4 will give you 2 moles of H plus ion. So in this case, the reacting capacity is 1, and in this H2SO4, the reacting capacity is 2. So that means I have 1 equivalent of HCl for every 1 mole of HCl. And for every 1 mole of H2SO4, I have got 2 equivalent of H2SO4, right? Why? Because the reacting capacity is 2 over here. And it's the same thing that we can do for the bases. We have seen that there is one way in which you can find out the equivalent, and that is by number of moles into volume, right? There is another way. The second way you can find out the equivalent of solute is by the mass of the solute divided by the equivalent mass of the solute, right? So how do you find the equivalent mass? molar mass divided by the n factor. Now you know how to find out the n factor. In the previous we have seen that how to find out the n factor, right? And mind it, since there is one h plus over here, so n factor is 1 here, n factor is 2 over here, n factor is 1, n factor is 2 over here, depending on the number of species. As I told you, n factor is a measure of is the number which tells you about the reacting capacity. So equivalent of solute is mass of solute divided by the equivalent mass of the solute. So equivalent mass is molar mass divided by n factor. You know the n molar mass very well. How to calculate the molar mass? You just divide it by the n factor. You get the equivalent mass. Plug it over here in the denominator, and knowing the mass of the solute, you can easily calculate the equivalent of the solute. Right? Okay, an extra tip for you. An extra tip for you. You know that normality is the equivalent of the solute divided by volume of solution liters. We have done in the start of the lesson. So from this, we can see that equivalent is equal to N into V. But there is another catch over here. You know, the a very important concept here that you know both the equivalent and moles are related to each other. But how they are related? They are related to each other. So this is the mole, this is the number of mole, this is the number of equivalent, right? So they are related by the n factor. So if you know the moles, you for example, suppose we talk about sulfuric acid, you know the mole. Suppose you know the mole. So what is the n factor? It's 2. You just multiply the mole by 2. You will get the equivalent for that, right? So just using this expression over here, what I can find out equivalent of the solute is mole of the solute into n factor from this equation. And you know, sorry, the normality, the n by v will be the molarity. So normality will be equal to molarity into n factor. So this is a very, very important relation over here, right? Okay. And at last we will start about the dilution law, and we will culminate our discussion today with N1V1 and N2V2 and how to use it, right? Suppose I have a solution, right? A solution having, okay, notice the number of the red dots here, 6, okay? So, and water level till here, okay? Now, if I add some more water to it, now what happens here? The water level increases, that I know. What happens to the number of these solute particles? It remains 6. 1, 2, 3, 4, 5, 6. Why it is remains 6? Because I have not added, I have not subtracted any number of solute here. I just added solvent. So yeah, I diluted it. Number of the solute remains the same. So what happens here? Initial number of solute and final number of solute. Suppose this is the container 1, this is the container 2. So after adding some water to it, then the water level increases. It was initially suppose N1 and the volume was V1. Now the volume becomes V2 because the volume changes. So is the concentration, because on dilution the concentration will decrease. But the thing is, does the number of solute changes? No, it doesn't. On dilution, the number of solute particles amount remains the same. So equivalent 1 equal to equivalent 2 over here, because the equivalent is the amount of the solute. So before dilution and after dilution, the equivalent is same. So N1V1 equal to N2V2, because we already know, we have seen so many times that equivalent can also be expressed in terms of N into V. But if you take an example over here, now suppose if you need to prepare a 250 milliliter of 0.5 normal NaOH from 2.5 normal stock solution means for whom we know the concentration. So you know this for 2.5 normal. So initial N1 was 2.5 and initial volume, what volume of the stock solution is required? So I don't know about the V1. So like V1 is not known to you. What is N2? N2 is 0.5 normal. And what about V2? The V2 is given to with 250 milliliter. So it's easy. Now you know, as we added some water to this, and 0.5 zero point 0.5 normal from 2.5, so the concentration decreases. That means some dilution is occurred. So okay, so but the number of equivalent of the solute remains the same, right? So that's why N1V1 we can use this equation. N2V2, what is N1 over here? N1 is 2.5. This is what is stock solution. V1 I don't know. What is the N2 over here is 0.5, and what is V2 is 250, right? From this you can easily calculate zero point 0.5 by 250 divided by 2.5. Okay, so it goes like this: 5 5 550. So it comes out to be 50 milliliter. So 50 milliliter of stock solution you must take added. So how do you find out the amount of water added for dilution? Let's suppose V1 is not given to you. So using N1V1 equal to N2V2, you can easily find out the V1, right? You can easily find out the V1 here. Okay, so once you find out the V1, so you find out the volume of the stock solution. Okay, now suppose V2 is known to you, and now you found out the V1. So what is the volume of water added? So that is V2 minus V1. That's simple, because when you add some water and make this final solution into V2, so the volume increases. So the increase in the volume is what actually the volume of the water, right, added. So these are the different type of basic problems that can be asked in this kind of topic. So I hope all the concepts, basic concepts of N1V1 N2V2 and the normality is clear over here. Thank you for so much for listening.